Hi everyone, my name is Maria Winters and I'm a PhD candidate in the UCLA Coastal Flood Lab. Today I'll be talking about the physical monitoring of the Cardiff living shoreline that the UCLA Coastal Flood Lab has been conducting there over the past 3 years. So Cardiff State Beach is located in northern San Diego County. It's a low-lying sand spit between the Pacific Ocean and the San Elijo Lagoon, and is also backed by critical Highway 101, which is vulnerable to flooding and damage, and in fact has been closed over 40 times in the past. Here are a couple of photos demonstrating the overtopping and the damage that the highway has sustained in the past. The historic revetment, which you can actually see here, and nourishments have been insufficient in protecting the highway. So to address these issues and to adapt to rising sea levels, the construction of a novel hybrid dune living shoreline project was completed in June 2019. It consists of a buried revetment topped with a sand berm and a cobble toe. And it aims to provide resilient and adaptive protection to Highway 101, to restore native dune habitat, including native vegetation and wildlife, and finally to improve pedestrian beach access. And here we can see Cardiff State Beach before and after the construction of the project, with the native vegetation, sand fencing, and the 6 pedestrian access ways visible in the photo. The UCLA Coastal Flood Lab has been monitoring the project both during and post-construction. From the construction surveys, we obtained valuable information about revetment and cobble size and placement, which will be particularly useful for future modeling efforts. And we can see some of that here in the drone imagery and transects. The surveys also captured opportunistic substrate placement, such as additional sand and cobble that was obtained during dredging and cobble sorting. So Cardiff experiences high significant wave heights and long periods in the winter. And looking at the data from the nearest sea dip buoy, wave heights in dark blue vary from 3 to 5 meters, and peak periods shown below often were greater than 15 seconds. The total water level elevations shown in red equaled or exceeded the dune toe elevation in purple. Therefore, the dune was exposed to wave attack often this past winter. And for reference, the historic beach crest elevation was also around 4 meters at the 88, indicating that without the project, water levels would have reached the highway. And here are some photos from this past winter showing the run-up traveling past the dune toe and into the pedestrian access ways. Okay, so what kind of damage did those high water levels produce? Here we can see erosion from last winter shown in red, which mostly occurred in the lower beach. And the dune was mostly untouched, indicated by white, representing 0 to minimal change. And the erosion from the previous winter was also similar. The dune toe is indicated by the blue dashed line, and we can see that some erosion did occur at the toe, mostly in this region here, which actually did not occur during the first 2019 to 2020 winter season. And taking a look at these 3 profiles from selected UAV surveys extracted along existing sea dip mop transects, we can see the lower beach erosion and the dune toe erosion in more detail. Critically, this erosion at the toe exposed the buried cobble berm. And here are some photos of the erosion and the damage at the dune toe, which resulted in slumping of the wind fencing and the exposure of the cobble berm. And that fencing was either trimmed or completely removed, depending on how bad the damage was. And to address this, dredged material from on-site San Elijo Lagoon mouth, which is just north of Cardiff, was placed along the entire project length, captured in our UAV imagery. So in addition to marine forced erosion, our UAV surveys captured a gully formation in the pedestrian access ways that formed after intense rainstorms the past 2 winters. These were caused by water from Highway 101 that focused into the backshore and into the walkways, causing movement and settlement of the rock. They reached a depth of about ½ meter, which we can see here in the transects taken from UAV DAM or from the UAV DEM data. And these required emergency attention and maintenance. And additionally, there will be an additional hydrology study that will soon be underway to address this in more detail. So overall, the project has been successful in reaching most of its intended goals. And I've also listed a summary of all the points I've talked about in this video. And an important implication, design guidance and scientific observations of these novel hybrid dune structures is lacking in the literature. And this project will serve as a critical example to future projects on the West Coast. I just want to quickly acknowledge all of the many project collaborators listed here and the works that I've referenced. And thank you all so much for your time.